Hey explorers, did you know that steam engines, hot air balloons, car tires, and even baking have something in common? What? Around 1787, Jacques Charles, a French inventor and scientist, used his observations on gases to develop Charles's law, which affects so much of the world around us. Let's explore what it means to our daily lives, as well as do a fun and easy experiment to demonstrate. Charles's law states that the volume of a gas is directly proportional to its temperature. This means that the same volume of gas, like in this balloon for example, expands and takes up more space when heated up, or shrinks and takes up less space when cooled down, even though there's no air taken away or added. You might be thinking to yourself, this sounds a lot like density, and asking yourself, what exactly is the difference between volume and density? Volume is how much space an object or substance takes up, whereas density is how much space that object or substance takes up in relation to its weight or mass. In this example, the weight of the air doesn't change, just the space it takes up. Think of a hot air balloon. Once the balloon is full, no air comes in or out, but the balloon gets big and it starts floating into the sky. This is because the torch in the balloon heats up the air and increases the volume, which lowers the density. This is because the space the air takes up inside of the balloon is larger, but the weight stays the same. With the balloon full of air that is less dense than the air outside of the balloon, it's able to lift off of the ground. Likewise, lowering the heat of the air inside the balloon increases the density and allows the balloon to float gracefully back to the Earth. Jacques Charles actually was a balloonist and invented the hydrogen balloon, which he flew for the first time in 1783 with fellow inventor Nicolas Robert. They actually managed to get it 1 mile up into the air. And keep in mind, this is over 100 years before the Wright brothers had their first flight. The change in temperature of air affects the volume and therefore the density. Hot air rises above cool air. This is why hot air balloons work, and it's also why if you're ever near a fire, you'll notice that the smoke and hot air goes up. If you're ever caught in a fire, remember to stay low to the ground, where the air still might be cool and clean enough to breathe. Also, to stop, drop, and roll if you're ever on fire. To visualize how this works, you'll have to envision air on a molecular level. Air is made up of molecules, just like everything else. And just like everything else, when heat is added, those molecules start moving around and getting excited. They move apart or expand, and the object or substance they belong to becomes larger. I always like to envision molecules dancing when they're heated up. Have you ever seen strips of metal across a bridge with just a little bit of room in it? This is there because the bridge expands in the hot summer heat and shrinks back down in the cold winter. This little gap helps make sure that the bridge doesn't get too big for the space it's allowed and then buckle and distort. Now I know some of you are wondering how baking fits into all of this. When you mix up a cake batter, there's air inside of the batter that goes into the oven. As the cake cooks, the air bubbles expand inside of it, allowing the cake to rise, giving it a spongy texture, and hopefully you end up with a delicious cake. To see Charles's law in action, let's do a quick experiment. I'm gonna go gather my supplies.
Science!
I'm back in the lab with everything I need for today's experiment. The materials you'll need are a balloon, a bottle, 2 bowls, some hot water that you can make in a kettle, stove, or microwave, some cold water, and some ice. This experiment is quite simple but allows you to see some very cool properties of gases. Step 1 is to stretch your balloon over the top of your bottle. There we go, that's nice and secure. So then we can take our hot water and pour it into our first bowl. There we go. Now we can rest the bottle inside, and what we'll start to see is that the air inside the bottle immediately starts to expand because heat has been introduced. But no extra air is going inside of that balloon. It's just that all of that air is taking up more volume, so the balloon expands. Similarly, if we put our cold water into this bowl, add some of our ice in. Woo. We'll see that the balloon starts to deflate because the air cools down and takes up less space within the bottle and the balloon. Sometimes it just takes a second to cool down. But we can already see that it is decreasing in size. Yeah, you can see that balloon coming down and eventually will entirely deflate. And now after inflating in our hot water and then cooling it down in our cold water, our balloon has deflated back to where it was when we began. Fun note, you might not want to use plastic as it did distort in our hot water bowl. If I was doing this experiment again, I would try a glass bottle. With some simple household items, we can explore Charles's law, learning how temperature affects the volume of gas. Almost everything shrinks or expands when it's heated and cooled. Water and ice actually have a very fun effect in that they act opposite to what you would think. When water cools down to become ice, it expands and becomes less dense. This is why ice floats on water. For more observations about the world around us, subscribe to Clayton's Exploration Station on YouTube and social media. Plus, for this experiment about Charles's Law or our other experiments, you can visit our website, explorationstation.net. Now you stay curious out there, explorers.
Clayton's Exploration Station.